Hello, everyone, and thank you for attending our presentation. My name is Özkan Çiçek, and today I will be presenting the results of a data-driven research project, which is titled Demand Forecasting Performance Using Multi-Channel Sales Data, a Comparative Analysis of E-commerce and Traditional Channels. This work has been carried out with the guidance of Professor Dr. Serap Ulusam Seçkiner and Assistant Professor Dr. Yunus Eroğlu at Gaziantep University. Our study focuses on a real-world industrial case from the polypropylene synthetic yarn sector in Turkey, where forecasting accuracy plays a vital role in production planning and customer service performance, especially when sales occur through multiple distribution channels.
In this presentation, I will first introduce the topic and explain why demand forecasting is important in multi-channel environments. Then, I will talk about the purpose of the article and the dataset used. After that, I will describe the forecasting methods, the limitations of the study, our findings, and the conclusions we reached. Today, many companies sell their products both through traditional sales channels and through e-commerce platforms. While this brings flexibility, it also makes forecasting harder. Especially in e-commerce, demand can change suddenly and companies have to respond quickly. For a B2B company like a yarn manufacturer, forecasting helps with planning production, avoiding waste, and keeping customers happy. The goal of this study is to compare two simple forecasting models, autoregressive integrated moving average and simple exponential smoothing. We wanted to see how well these models can predict demand for 5 different product groups in 2 channels, traditional sales and e-commerce. By comparing the results, we can understand which model works better and whether each sales channel needs a different approach. We used sales data from a company that produced polypropylene synthetic yarn. The data includes monthly sales for 5 product groups from January 2023 to December 2024. Each product has data from both sales channels. The products are greenhouse twine, carpet yarn, package yarn, bale twine, and plastic packaging yarn, and the sales are given in kilograms. Here is the actual data. As you can see, the values vary by product and channel. Some products have stable demand while others are more irregular. E-commerce data is especially more volatile with sudden ups and downs. We apply two models, simple exponential smoothing and autoregressive integrated moving average. Simple exponential smoothing is a basic method where recent data is more important than older data. It has a parameter called alpha, and we tested alpha values from 0.1 to 0.9 to find the best one. For autoregressive integrated moving average, we checked if the data is stationary, used differencing, and found the best parameters using ACF and PACF pilots. In simple exponential smoothing, we first tried different alpha values and selected the one with the lowest forecast error. We started the forecast using January 2023 data. Simple exponential smoothing is good for data without trend or seasonality. However, in our case, it struggled with the fast changes in e-commerce demand. It was more successful for traditional sales. At first, we used mean absolute percentage error to measure accuracy. The formula is the average of absolute percentage errors. But when actual demand is 0 or close to 0, mean absolute percentage error gives very high or undefined errors. Since e-commerce sometimes has near zero sales and mean absolute percentage error was not reliable. To solve this problem, we use symmetric mean absolute percentage error instead of mean absolute percentage error. This metric gives a more balanced error, especially when sales are small. It limits the error to a maximum of 200%, so it gives more stable results. We use symmetric mean absolute percentage error to compare autoregressive integrated moving average and simple exponential smoothing fairly. For autoregressive integrated moving average, we use Minitab software. First, we check the time series pilots and did an ADF test to make sure the data is stationary. If not, we apply differencing. Then we look at the ACF and PACF pilots to choose the parameters. We found that autoregressive integrated moving average 112 gave the best fit for all product groups in both channels. This slide shows autoregressive integrated moving average forecast results. Compared to simple exponential smoothing, autoregressive integrated moving average handled irregular demand better. It followed the trend and small changes more effectively. Especially for e-commerce, where data is less predictable, autoregressive integrated moving average was more accurate.
There are some limitations too. The data only covers 24 months, so we could not include seasonal effects. Also, we did not use any external factors like prices, promotions, or economic conditions. In future work, this could be included to improve accuracy. We could also test machine learning methods. When we look at the symmetric mean absolute percentage error values, autoregressive integrated moving average gave lower error rates for all 5 product groups. In traditional channels, symmetric mean absolute percentage error was around 8 to 12 percentage. In e-commerce, the symmetric mean absolute percentage error was higher, around 21 to 29 percentage, but still better than simple exponential smoothing. Because in simple exponential smoothing, the rates varies between 9 percentage to 12 percentage and 27 percentage to 32 percentage. This situation shows that e-commerce needs more advanced forecasting methods. These results tell us that demand forecasting must be done separately for each sales channel. Even if the product is the same, demand behaves differently in traditional and e-commerce sales. Simple methods like simple exponential smoothing can work in stable environments, but in digital platforms, more flexible models like autoregressive integrated moving average method are needed. To sum up, autoregressive integrated moving average was the better model overall, especially in dynamic e-commerce settings. This study shows that using the same forecasting model for all channels is not a good idea. Businesses should analyze each channel separately and choose models that match the data behavior. This helps reduce errors, improve planning, and respond better to customer needs. And thank you for taking time to study and present our work.